What we're going to do today is I'm going to give you a function. Usually, most of them are linear today. And I'm going to ask you to find the inverse of the function. The notation for inverse of f of x is just f of x with a negative 1 kind of tucked up there in the middle. The negative 1 doesn't mean to the negative 1 power or times negative 1 or anything. It's just the name of the function, and then there's that negative 1, which means the inverse of f of x. Okay? So we're going to find the inverse of the function, which is kind of like an opposite of the function. And we'll see when we graph them kind of the relationship they have. And this is a very easy process. There's 3 steps to it. 2 of the steps do not involve math. Okay? So it's right up some of your alley. Step 1, change the f of x to a y. That does not involve math. Okay? Change the f of x to a y. Step 2 also does not involve math. Switch the 2 variables. So we change the name of the function, which could be f of x or p of x or g of x or whatever. Change that to a y and then switch the 2 variables. And then the third and final step, which is the only one that involves any math whatsoever, is now we have to get the y by itself. So we're going to add the 7 and then divide by 3. And then I'm going to write my answer in slope-intercept form. So over here on the left side, each part of this x plus 7, each part gets a 3. So what you have is 1/3 x plus 7/3. Okay. So the inverse of f of x is 1/3 x plus 7/3. That's the opposite function to 3x minus 7. 3 steps. Change the function name to something a little more usable, which is a y. Switch the variables. Solve for y. Now, you're also going to be asked to graph these on your homework, both of them. To graph a line, you go to the y-intercept and take the slope. I really shouldn't have to teach mx plus b anymore. This line we went to -7 and went up 3 over 1. It's right here. This line we went to 7/3, which is 2 1/3, and went up 1 over 3. The relationship between these 2 lines is they are reflections of each other. Basically an x that's at a 45-degree angle that reflect around that purple dotted line. They will always intersect at the bisector of the first quadrant, y equals x. When you graph them, they should always intersect at that bisecting line, the line that bisects the first or third quadrants. If you graph them and then fold your paper on that purple dotted line, the 2 sides will line up. Okay? Your turn. Find the inverse of f of x equals 2x plus 1. Okay, so step 1, change the f of x to a y. Step 2, switch the variables. Still haven't done any math. Then I need to subtract the 1 and divide everything by 2. Putting that into slope-intercept form, I would get 1/2 x minus 1/2. Both of those get a piece of the 2. So there's your inverse. The graph, I didn't ask you to graph it necessarily, but but you'll see once again that they intersect along that line, which I made a thick yellow, like highlighter type line. They intersect on that line. 45-degree angle X. Everybody doing good so far? All right, let's try one more. All right, I want you to find the inverse of this function, and then I want you to graph it and its inverse on an xy axis. The inverse, change f of x to y, switch the variables, add the 4, divide by 5, put it in slope-intercept form. My inverse is 1/5 x plus 4/5. So when I graph those, for the original, my y-intercept is -4. And my slope is going to be up 5 over 1, up 5 over 1, up 5 over 1. Connect those. Looks like that. Steep slope. That's the original f of x. The inverse, my y-intercept is 4/5, which is just short of 1. You can see that little orange dot I put in there on the purple y-axis. And now I'm going to go up 1 over 5 for the slope of 1/5. And repeat that a couple times so I get a solid line and connect.